Today we are going to talk about why it is so important for firefighters to be able to effectively manage heat stress and how the higher breathability of GORE-TEX moisture barriers and the GORE-PARALLON liner system can help with this. Structural turnout gear is worn for protection. However, working hard in turnout gear can pose significant heat stress challenges. This can result in unmanageable increases in body core temperature, impacting the firefighter's safety and performance. Even seemingly small increases in body core temperature can impair the firefighter, adding risk to the job. As core temperature rises above a certain point, shown here as the onset temperature, so rises the severity and prevalence of the issues related to heat stress. Issues such as impaired hearing, exhaustion, diminished motor control, and mental sharpness. The objective is to help the firefighter maintain their body core temperature as close to normal as possible to minimize the effects of heat stress. Rehab protocols, physical fitness, and proper hydration are important, but choice of turnout gear technology is a critical decision in managing heat stress. An important part of how humans manage excessive heat stress is through sweating, and the environment and gear being worn can affect this mechanism. When sweat evaporates, it cools the body. Sweat must leave the body through evaporation to have its cooling effect. Simply dripping off as water does very little to help the body cool. Layers of protective clothing like turnout gear get in the way of sweat evaporation. The best gear technologies get in the way the least. We want to engineer turnout gear to make it more breathable to better allow sweat to evaporate, leaving the body and having its cooling effect. Breathability of clothing can be measured by its resistance to the transmission of water vapor or sweat through it. The lower the evaporative resistance, the more breathable the gear. Gear with lower resistance is more able to allow for sweat evaporation to occur to help maintain body core temperatures as close to normal as possible. So how well the mechanism of sweat evaporation works to cool the body depends on the conditioning of the individual, the amount of work being done, the environment, and the technologies used in the gear that affects its breathability. The environments we work in can impact body core temperature. Let's evaluate how core temperature can rise while wearing turnout gear and working in different conditions. Total heat loss, or THL, the current NFPA 1971 test used to evaluate this aspect of gear performance, is run at one relatively moderate condition: 77 degrees Fahrenheit, 65% relative humidity, and no sun or other radiant heat. But firefighters face many conditions in their jobs. We can see that in different conditions, while doing the same work, core body temperature will rise to different levels. This is because there are differences in how effectively the body can shed excess heat due to different environments. Working in hotter conditions will be more difficult. This result is expected, but of course firefighters cannot easily choose the environments they work in, but they can choose the technologies in their gear. We can then see how choice in moisture barrier technologies can drastically impact body core temperature. Shown here are higher increases in body core temperature due to using a different moisture barrier. There are differences in how effectively various moisture barriers allow the sweat to evaporate, leaving the body and helping to cool the wearer. There are differences in the resistance to the evaporation of sweat. It should also be noted that both turnout with GORE moisture barrier and turnout with non-GORE moisture barrier in this example had very similar THL test results. Yet clearly the two garments have different impacts on body core temperature when working in other environments. Simply working in the sun drastically changes results. THL, with its one moderate test condition, does not tell you everything about your gear's performance in other environments. This is because the resistances to breathability are different in different conditions. We can see this looking at resistances in one such condition. Let's look at turnout material performance in one such other environment. We can see the differences in the resistance to sweat evaporation in a widely accepted test used in comfort science, known typically as the RET test. The RET test is an ASTM method of measuring fabric breathability that looks at the resistance in conditions of 95 degrees Fahrenheit, 40% relative humidity, and no sun or other radiant heat. Remember that the lower the resistance, the higher the breathability. As a reference, stationware has an RET value or resistance of 8. In this chart, the resistances are shown for a range of outer shell thermal liner combinations with CROSSTECH black moisture barrier. Resistances are then shown for the same outer shell thermal liner combinations with CROSSTECH 3-layer moisture barrier, GORE-RT 7100 moisture barrier, and competitive moisture barriers. It can be seen that choice of moisture barrier, more so than the choice of thermal liner and outer shell, had the largest impact on resistance to sweat evaporation, and that choosing GORE and CROSSTECH moisture barriers make for more breathable composites. Additionally, the GORE PARALLON liner system showed even less resistance to sweat evaporation, further maximizing turnout gear breathability. With GORE and CROSSTECH moisture barriers and the GORE PARALLON liner system, composites offer lower resistance or maximum breathability, allowing the body's natural cooling process to work as effectively as possible. The RET test provides additional insight into the performance of different technologies and can be an important consideration in the selection of turnout gear. But knowing that firefighters face a range of environments, GORE has and continues to look even beyond RET and THL tests for performance in other conditions such as those with low-level radiant heat, the kind of heat from the close fire, a hot asphalt street, rooftop, or from the sun. GORE does this to help reduce the risk to firefighters' safety and maximize their performance with the gear worn today and will wear tomorrow. GORE moisture barriers and liner systems enable higher breathability to manage heat stress better in more conditions. For much of the information shared here and additional performance data, go to our website at www.crosstech.com/heat stress management. Insist on GORE moisture barriers and liner systems to manage your heat stress better.